one student asked me a question regarding so question is that there is a spherical surface, and over this surface the charge density is given by sigma naught sine theta. So this charge density is given, and I posted a wrong solution to this question due to some mistake. I took this theta from the xy plane in spite of from the g axis, so that's why the I apologize for that. So this is the, suppose this is z axis, these are the xy axis. Okay, so suppose this is x, yeah, y, and this is z axis. So yeah, so if theta is equals to 0, theta equals to 0 means theta will be 0 at z axis, and theta will be pi at opposite minus g cap direction. So here theta will be pi, and here theta will be 0. So on xy plane, theta will be 90 degree. Okay, so charge density is given like this. So if theta is 0, then sigma will be 0. If theta is equals to pi, in that case also sigma will be 0. And from, if we draw the graph of sine, so sine graph is like this, where this is the 0, this is pi, and this is 2 pi. So sine graph is positive between 0 to 2 pi, 0 to pi. So 0 to pi the sine graph is positive, and pi to 2 pi the sine graph is negative. But here in the polar coordinate, theta varies from 0 to pi. Hence the charge density over the sphere will be either positive or 0. It cannot be negative. In the previous wrong solution which I posted, there I took the theta from the xy plane by mistake. That's why I was getting some negative charge distribution on the surface, but I deleted that post. Now we so the charge density over the surface now is, due to this charge distribution, the correct charge density over the surface will be either positive or 0. 0 will be at 2 point at theta equals to 0 and theta equals to pi, and rest of the surface will have the positive charge density. That's why, so it's a dipole moment about origin. So net, if you calculate the total charge will be sigma naught sine theta, and yeah, so total charge will be sigma ds. So if you calculate this will not be equal to 0, because there is only positive charge distribution, there is no negative charge distribution to cancel that. That's why the total, if total charge is not 0, then the dipole moment which you will calculate, will not be same at any coordinate system. So means that it can be 0, this dipole moment can be 0 at a particular origin. So if you shift your origin accordingly, the dipole moment will change. So you I hope that you have learned in the class that if the total charge of the system is 0, then dipole moment you calculate will be independent of the space. You can take anywhere your the origin you can take anywhere. But if the total charge is not 0, then the dipole moment will not be 0 if you took origin at different locations. So yeah, so if you take origin at the center of the sphere, in that case this dipole moment will be 0. But if you shift your origin outside the sphere, in that case dipole moment will not be 0. So this is the situation. So if you calculate the dipole moment considering the coordinate system has the same origin at the center of the, if the center of the sphere and the origin coincide, in that case dipole moment will be 0, because the formula for dipole moment is dq r vector in this integration, and dq will be given sigma ds r vector, this like this. And if you have chosen your origin at the center, this r vector will have correspondingly its opposite vector, which will cancel this integration. Means that if you are doing the integration, suppose at any, so this is r vector and this is the ds. So if you are doing the integration, there will be a corresponding situation, corresponding opposite r vector, because you are doing the integration over the whole surface. So in that case, there will be r minus r vector. So contribution from this opposite side will cancel this side, and contribution from this side will will cancel by this side. So yeah, because of due to negative parity of r vector, this dipole moment will be 0 if you choose your origin at the center of the sphere. If you choose origin out of the sphere, in that case dipole moment will not be equal to 0. So you can check that.